All right, so today we're going to review graphing absolute value functions. So first, let's go over our translations that we talked about first semester. So remember, our absolute value graphs are V-shaped, whether they're facing up or down. Okay. So then on the inside, that determines if we're moving left or right. So remember, if it's positive, we're moving left. And if it's negative, we're moving to the right. If we have an addition on the outside, we're moving up. And if we're subtracting, we're moving down. And then our A value in front, we have a couple of things that tells us. The first one, if the absolute value of A is greater than 1, it's a vertical stretch. And if the absolute value of A is between 0 and 1, so we have a fraction, we have a vertical shrink or compress. Okay, the other thing we talked about with A was if A is negative, or A is less than 0, then we reflect the x-axis, meaning that our absolute value is facing down. Okay. We also talked about how A equals our slope only when we look at absolute value functions. Okay. All right, so looking at this first example, g of x equals 2 times the absolute value of x minus 1 plus 2. So stating what we know, so a equals 2, which we're going to use as our slope, but remember this is also a vertical stretch. Because of the minus 1, we're going to move to the right 1, and then we're going to go up 2. So I'm going to go ahead and plot that first point, right 1, up 2. And remember that is called our vertex. And then we can also state our axis of symmetry. As x equals 1. So that's that dashed line that goes through our absolute value function or through our vertex. So we show that symmetry from both sides. Okay. So I'm going to use our slope on this one. We're going to go up 2 to the right 1 to make our V. And then we're going to go up 2 to the left 1 to make the other side of our V. Okay, so there's our absolute value function. Let's review a couple of things. Remember, our domain is from negative infinity to positive infinity. And our range is based off our bottom value. So I'm going to go ahead and draw our horizontal line here. This is when y equals 2. So our range is from 2 to a positive infinity. Okay. The other things we talked about first semester, we talked about minimum and maximum. So this is going to be a minimum because it has a bottommost point. We have no x-intercepts. And then our y-intercept is going through at 0, 4. Okay. All right, so, and I just filled all that out. Sorry about that. Let's see, did I figure out anything? Oh, in behavior. So in behavior, that's our arrows, or we can write up, up. Okay. Sorry about that. All right, looking at B, we're doing the same thing. So we have h of x equals negative 3 times the absolute value of x plus 3 plus 4. So let's talk about how we're translating our graph. So x plus 3, so we're going to be moving left 3. We're going to go up 4. Plot that point. and that's our vertex. So I'm going to go ahead and write that down. Our vertex is -3, 4. And we can state our axis of symmetry, our line that cuts our graph in half, as x equals -3. Now let's look at our value for a. A equals -3. So remember that is our slope for absolute value graphs. So we're going to go down 3 to the right 1. And I'm going to keep doing that until I go through my x-axis and my y-axis. And then we're going to repeat the same thing on the left. All right. So our in behavior we can see is down, down. Our domain is -infinity to +infinity. Our range is different here. So we start at the bottom with our arrows. So we're going to start at -infinity. And then our maximum value is 4. Our x-intercepts, here we're going to kind of approximate. So let's say we're at negative, I don't know, 1 2/3. And let's say -1, -2, -3, -4. Let's say -4 2/3. 0. Our y-intercept is easier to find. That's going to be a -5. Since we have a topmost point, we have a maximum, and that maximum value is the y value of our vertex, so 4. All right, and the last example, what if we want to go backwards? What if we want to look at the graph and write our equation? So I'm going to write out our general form. F of x equals a times the absolute value of x minus h plus k. So let's figure out what is our graph doing. So 1, 2, 3. We're moving left 3. We're moving down 2. And then we need to figure out our slope. So starting at our vertex, we're going to go up 1, 2, 3, 4, and to the right 1. So a equals 4. And we know it's positive because our v is facing up. So I'm going to plug in what we know. F of x equals 4 times the absolute value of x. So remember, when we go left 3, we're always thinking backwards. So this is going to be plus 3. And then down 2, so we're going to subtract 2. Okay. So for today, your homework, you have a review on SAPIS Realize, and it's short. I want to say it's 10 questions or less, if I remember correctly. And then you're also going to have 2 Edpuzzle videos. Over 8.2, looking at quadratic functions. Okay. If you have any questions, make sure you email me.